Hello guys, let us go through the concept of covering and we will be discussing about vertex covering in this lecture. So basically covering is nothing but if you are learning about vertices, you will be getting more information about the edges, so you will cover them by using something else. So that is the concept of covering. We may get a clear idea after visiting a example. So here is an example. Uh, Here we have 5 edges and 4 vertices. The vertices are A, B, C and D and the edges are E1, E2, E3, E4, E5. We need to take the subset of all the vertices. So it directly states that we are taking a subset of all the vertices. Um, so let's assume B1 is a subset of B and D. B has a 3 visiting edges E2, E3, E4 and D has the 3 visiting edges E1, E3, E5. A small subset of all vertices are B and D. If we combined these all E1, E2, E3, E4 ends with all the vertices. Hence the collect set that is nothing but a small set V1 is a vertex for our particular graph. So this is the concept. Basically you will take a small subset of a whole vertices and you will checking whether it is covering all the vertices. If it is covering all the vertices, it is indirectly stating that a given graph is a vertex set covering. Yeah. So this is what which is given in this theory explanation. A subset of vertices is called a vertex covering. And a graph G, if every edge of G is incident should or covered by a vertex in subset of V, that is V1, V2, V3 and so on. And, and yeah. Now let's see that example. Here V1 equal to B and D. As already said, B have 3 edges and D have 3 edges. We will if we union we will get all the vertices. Now we all know about vertex covering. Then what is minimal vertex covering? Basically in some situation there is no need of particular vertex. That is called minimal vertex theory. That means if all the vertices in a set are mandatory to maintain a vertex covering, then that set is a minimal vertex covering. After removal of any subset, the property will be lost. So in that situation we will be saying that it is a minimal vertex covering. Here V equal to B and D, right? So if we remove B vertices, then it will only be the vertices D. The D contains only 3 edges. What are they? E1, E3 and E5. Now we cannot combine. If we combine only, we will get all the wedges which are in the vertices, but D only contains 3 edges, so we cannot union. So it is mandatory. Let's take V1 equal to A, B and C. So if we take any of one vertexes, we cannot solve, right? So it is also a mandatory. If we take V2, A, B, C and D, if we take the D, then we cannot find the answer, so it is not mandatory. We can also do it in A, B, C and C. So D is an extra thing, right? So it is not mandatory. That is what the minimal vertex covering is about. Yeah, and here VG indicates that the cost of a minimal vertex covering. So here there are two mandatory. So in PG that is equal to the value of 2. And here where the lecture ends. Thank you.